Next, let us talk about strain gauge structure. We have two types of strain gauge. This one is the wire gauge and this one is foil gauge. Both gauges have something in common. They are made of electric conductor. This is made of wire, while this is made of metallic foil. These electric conductors are laid onto the gauge base in order to hold the conductor in position. This is the gauge base and this is the gauge base. The gauge base here is an electrical insulator. That means it doesn't conduct electricity. It serves as the electric insulator in order to separate the strain gauge from the test material in terms of the current. This gauge base here is attached to your test specimen by using additive, so that whichever elongations endured by the test specimen shall be effectively transferred to the strain gauge. You see this conductor, wire and the foil forms a circuit. Normally this is made of thin layer of metallic item. The circuit is arranged in the form of loop, something like this, for the wire gauge. As for the foil gauge, it is arranged in this manner. As this metallic layer here is very thin, can easily be damaged. Therefore, you will need to handle it with care. Normally, we will prevent direct contact of your finger with this foil or the wire, as we do not like to disturb the circuit or cause any damage to the strain gauge. This refers to the gauge length and this refers to the gauge length. Now, if the strain gauge elongates, this part will elongate, leading to finer foil or wire. This increases the resistance, and through computations, we are able to determine the strength. At the end here, we have gauge tab. This is connected to the gauge lead, and this gauge lead is supposed to be connected to the wire and then to the data logger for data acquisitions. This gauge lead is a very fine conducting wire connecting to sensitive elements of the strain gauge. You will need to handle it with care as well to prevent it from detaching from the strain gauge. You see a loop of sensitive elements on the strain gauge. At the ends are the end loops. This forms a grid of sensitive elements. Instead of having a long strain gauge, the looping here maintains the length of the sensitive element while reducing the size of the strain gauge. And then we have measurement axis. You see the arrows here. These arrows are the measurement axis. You need to identify the locations where you need to install the strain gauge. Use this measurement axis to install onto the specimen. Align it properly, matching the measurement axis. This will be the exact locations that you want to do the measurement. There will be a thin layer of cover film overlaying the sensitive element. This is to protect the sensitive element and to insulate the sensitive element. The additive will ensure the strain gauge is attached to the test specimen. you need to choose the right additive to ensure it is bonding properly on the surface of the specimen.